Okay, so this is kind of a long question, but let's do it. So our goal is to find the pH of the solution. And so this is pretty much, we're mixing 35.4 milliliters of 1.5 molar CSOH, which is a strong base, and 55 milliliters of 1.43 molar of hydrocyanic acid. So our first step is to find the moles or molarity, but we're going to do moles since it's pretty easy, which is just the molar. So let's start with CSOH, moles, it's just the molarity times liters to find moles. So the molarity is 1.50 times, and since it's times liters, we have to move this, so 3 times, so 0.0354. So once you do that, that comes out to be 1.50 times 0.0354, 0.0531 moles. Now we can do that for our, for HCN. So HCN moles equals 1.43 molar times 50, so 0.0550, which that comes out to be, let's see, 1.43 times 0.0550, 0.0787 moles. So now once we have our moles set up, we can pretty much set up our equation. So for when we're mixing these, so CS is almost acts like a spectator ion pretty much, so it's not really used in the equation, so we can just use OH instead. So our equation is going to look like this: OH minus plus HCN, because we're mixing these two, and then it goes to H2O, which is a liquid, plus CN, which is the conjugate base. Okay, our next step is to identify that this goes in 100% because it's a strong base. So when it's a strong base, it always goes 100%, or strong acid, and when it's combined, it always goes 100%. So our initial, we can use moles since we are doing this equation. So for our OH, our initial is 0.0531, and for our HCN, our moles are 0.0787, and this is liquid, so it's nothing, and this is 0. So now for our change, we can find the limiting reactant first. So which one's smaller, 0.0531 or 0.0787? And it's this one. So this is our limiting reactant. So since it's 100%, it is minus 0.0531, and for here it is this. It would be coefficients where you're coming from, where you're going, but since this is 1 and this is also 1, it's just minus 0.0531 plus 0.0531. And so that's our change. So this comes out to 0. This 0.0787 minus 0.0531 comes out to 0.0256. And now this is just 0.0531. Now we have our equilibrium pretty much moles, and what we can do is we can find the pH using the Henderson Hasselbalch equation. So this is just pretty much the negative log of our Ka plus the log of our Cn minus over our conjugate acid, which is HCN. And our Ka, it's pretty much just, let's see, our Ka is 4.94 times 10 to the negative 10. That would be given. That's just, it should be there. So now we can just plug all these numbers in. So pH equals the negative log of 4.94 times 10 to the negative 10 plus the log of, we can do 0.0531 over our HCN, 0.0256. Now, let's just plug all that in the calculator. So, negative log 4.94 times 10 to the negative 10, parentheses, plus the log of 0.0531 and 0.0256. And what do we get? Our pH is 9.62. And that is our answer. That is the pH of the solution.